Okay, 11.2, here we go. This is a chapter on area, and we're only covering the first two sections. But first thing to know is that when you measure things in terms of 2 dimensions, you always need to use units to the second power. Sometimes we call those square units or units squared. I think the best way to write it out is something like this, or just write out u with a power 2 after it. All right, and understand that in our brain, this means a little series of squares, yes? So that's kind of how we're measuring area, is tiny squares of length 1 by 1. So then how do you measure the area of a triangle? Because clearly putting little squares in here is going to be challenging with those sides. Well, I think most of you know the formula. Fine, 1/2 base times height, right? First note, our dimensions that we're multiplying must be perpendicular. If they are not, then you have to go back to square one and figure out how to get those perpendicular dimensions. Meaning, if you have this side and this side, you can't multiply those two sides together and get the area. At least not now. You can in the future with some trigonometry. But, all right, so conceptually, why is this 1/2 base times height? Can you see the rectangle that this shape fits in? Well, there's a lot of ways to draw this out. I'm going to draw it out, I think, like this. That didn't work out so well. And assuming I have drawn a nice rectangle, I'm now going to split this rectangle in half. And now we can see that the area of the triangle occupies 1/2 of the rectangle that it fits in. All right? So that's one way to conceptually to think about why it's a half. Again, don't be fooled by things like this. You can use 3 different bases here, either that base or this base or that base. But whatever you do, always look for a perpendicular dimension. So in this case, maybe dropping that distance down, yeah. Or if you're going for this side, then you're going to look for that distance there. All right? All right. Area of a trapezoid. This is a little trickier. It has a 1/2, just like the triangle. It does have a height, just like the triangle. But now you've got 2 different bases. And you can think of a trapezoid as maybe a, I don't know, triangle that's been sliced off part of it, so that you don't have a pointy thing, but you've got actually 2 different bases. So we typically call that base 1 and base 2, whatever the sides are that are parallel. So we have to add those bases together and multiply by 1/2, multiply by height, and you get it. Now, we could distribute the 1/2 h times the b1 and the b2, and we would end up with a formula like this, which you'll notice now looks like 2 triangles. And let me show you those 2 triangles in the trapezoid, if you haven't seen this yet. So let's go draw that diagonal. So here's my base 1, here's my base 2, and here is my height, perpendicular, right? And so here I have a triangle, which is 1/2 h times b1, and then we have 1/2 times h times b2, right? Finally, there is one other way to think about a trapezoid besides 2 triangles. You can think of it as a median of, let me try that again. Let's see. Find the median of the trapezoid. And the median of the trapezoid would be a line which goes from that leg to that leg of the trapezoid, specifically bisecting it in half. And notice I could then take this little piece and we could flip it up and fill in that piece there. And then likewise I could go to the other side and do a similar process of taking this triangle, flipping it up and putting it in there. So then we would end up with a median times the height. And notice to get the median, you would have to do this little trick here. That is, you'd take your two bases, add them up, and divide by 2 to get the average. All right? I'm actually showing you notes for 11.3 as well. So this is kind of like a double case of notes. Parallelogram, finally. Well, do you see the triangle? Do you see the rectangle? Hopefully you can, since it's a parallelogram, we know opposite sides are congruent, so that's congruent to that. And again, if we find that little perpendicular height, careful, don't use the side length here, but this area here could be drawn over here. And so we would simply have height times base for my parallelogram. All right. Now, if you're looking at a kite, another four-sided figure, probably the best way to do it is to think about the diagonals. And again, notice how thinking about triangles helps me figure this out. Like, oh yeah, I can see it. That triangle's half that one, half that one, half that one, half that one. So basically this is a rectangle and I'm taking half of that purple rectangle. So that's why we take diagonal times diagonal divided by 2 as the area. All right? Well, best of luck as you work your way through 11.2 and 11.3 are the two assignments that you're doing. Okay?